Water goes up your nose, that's all, just water a splash. While diving into a warm lake, you barely notice it, you surface, laughing, wiping your face, you have no idea that something just crossed a border inside your body that almost nothing is supposed to cross. Your nose is not just an entry point for air, it's also a direct corridor toward your brain. And in this exact moment, something microscopic just used it. You are, for this story, a composite of dozens of documented cases. A teenager, a swimmer, a camper, someone who spent an afternoon in warm, still fresh water, a lake, a poorly chlorinated pool. Maybe a splash park with untreated water. The season is summer, the water is warm, often above 80 degrees Fahrenheit. That warmth matters. It's the exact condition a single-celled organism called Naegleria fowleri thrives in. Researchers sometimes call it the brain-eating amoeba, a nickname that sounds like fiction. It is not fiction. Within the first few days, you feel almost nothing. This is the quiet part. The amoeba has entered through your nasal passage and started migrating along your olfactory nerve. That's the nerve responsible for smell, and it happens to run in a place your brain's normal defenses barely patrol. Your immune system is excellent at killing threats in your blood. It is far weaker here in this narrow neurological doorway. So the amoeba moves slowly undetected by day 2 or 3. You start to feel what seems like an ordinary headache, maybe a stiff neck, maybe a low fever. You might think it's the flu or dehydration or too much sun. This is one of the cruelest parts of this condition. The early symptoms mimic something completely harmless, so most people don't seek emergency care yet. Inside your skull, the process has already escalated. The amoeba has reached your olfactory bulb, the brain structure that first processes smell. From there, it begins invading actual brain tissue. Your immune system finally recognizes the threat, and it responds the only way it knows how. Inflammation, but in this case, that response becomes part of the danger. Your brain is enclosed in a fixed space, bordered by bone. When tissue swells inside a space that cannot expand, pressure builds. Doctors call this intracranial pressure, and it is one of the primary things that makes this condition so severe. By day 4 or 5, the picture changes fast. What felt like a bad headache becomes confusion, sensitivity to light, nausea that won't stop. Some patients experience hallucinations, others lose the ability to keep steady balance. This is the point where the diagnosis, called primary amoebic meningoencephalitis or PAM, usually starts being considered, if it's considered at all. Part of what makes this condition so lethal is how rare and how fast it is. Emergency physicians see thousands of cases of viral meningitis for every one case like yours. So recognition often comes late. If it comes in time. Inside your brain, the amoeba is doing something specific at a cellular level. It doesn't just occupy space, it consumes tissue directly. Using structures scientists have observed under microscopes called food cups, small extensions that pull in and digest surrounding brain cells. That's part of where the nickname comes from. It is not a metaphor, it is an observed mechanism. Your brainstem, the structure responsible for regulating your breathing and heart rate, sits deep at the base of your skull. As swelling increases, pressure begins pushing brain tissue toward that stem, a dangerous process doctors call herniation. This is the point where survival becomes a race against time, measured in hours, not days. Historically, this race has rarely been won. According to the United States Centers for Disease Control and Prevention, the vast majority of documented cases have been fatal, with survival numbers historically in the single digits out of hundreds of confirmed infections since the organism was first identified in the 1960s by Australian researcher Malcolm Fowler, whose name the species carries. But not every case has ended the same way. A small number of patients have survived, most through a combination of rapid diagnosis, aggressive drug treatment including a medication called miltefosine, and induced therapeutic hypothermia, cooling the body to reduce brain swelling. Doctors involved in survivor cases, including physicians at the CDC and various children's hospitals in the United States, have described those recoveries as dependent almost entirely on how early the infection was caught. For you, in this composite scenario, the outcome from here depends on exactly that. Some patients reach this stage and are gone within a week of first exposure, others rushed into intensive treatment within the earliest window, walk out of hospitals. Months later, sometimes with lasting neurological effects, sometimes with none at all. The margin between those two outcomes is almost entirely about speed and recognition, not about the individual's health beforehand. Here's what makes this story matter beyond one lake, one summer, one patient. This organism has existed in warm freshwater around the world for millions of years. It isn't hunting anyone, it has no awareness of the body it enters, it is simply an amoeba doing what amoebas do, consuming organic material for energy, and your brain, biologically speaking, is organic material. The infection isn't contagious, it can't spread person to person, and overall cases remain extremely rare relative to how many people swim in warm freshwater every single year. But the specific vulnerability, that narrow nerve pathway between your nasal cavity and your brain, is a permanent feature of human anatomy. Every one of us carries that same corridor. What this reveals isn't really about one amoeba. It's about how fragile the boundary is between your outside world and your central nervous system, and how much your body relies on a defense system that mostly works until it encounters something evolution never prepared it for. Your immune system is built from millions of years of exposure to bacteria and viruses. It has almost no evolutionary experience with this particular organism in this particular location. So the next time water rushes up your nose in a warm lake, you probably won't think about any of this. Neither did you at the beginning of this story. That's exactly the point. The moment felt like nothing at all.